Section 2.4 is on solving addition equations, and we actually have done this already. The only difference here is that we could have a little bit of things with negative integers. So if you look at this problem, it says Baltimore's Fort McHenry Tunnel, if it were 1,176 feet longer, it would be as long as New York's Brooklyn Battery Tunnel. The Brooklyn Battery Tunnel is 9,117 feet long. How long is the Fort McHenry Tunnel? Okay, so from that we can see that the Brooklyn Battery Tunnel is actually the longer tunnel. Something to keep in mind here. What they did over here is they show this as kind of a balance, which first we would have to come up with the equation to be able to see that, but so we can make this addition equation. So if we let x represent the length of the Fort McHenry Tunnel, we take that plus 1,176 feet, that would be the 1,176 feet longer, then it would equal the Brooklyn Battery Tunnel, which is 9,117 feet. Okay, so this is an example of an addition equation because they're adding, and it's an equation because it has an equal sign. In order to solve an addition equation, we're going to use the subtraction property of equality, which just says that if you subtract the same number from both sides of an equation, you get a true statement. So the book uses an example here. If A equals B, then A minus C equals B minus C. If we use this in terms of numbers, we could say like if 5 equals 5, if these are equal to each other, if we subtract the same number on both sides, 5 minus 2 would equal 5 minus 2. Now I know that looks different than what's in your book, because in your book they have, A and B are different variables, but it's the same concept. Okay, and so like it says in this think box here, whatever we subtract from one side of the equation, we have to subtract the same thing from the other side to keep it balanced. Okay, and that gives us an equation that's equivalent to the original equation. Okay, so think about this balance like we talked about at the beginning of the page here. And so if these things are balanced, if we take away the same amount from both sides, from the left side and the right side, then it stays balanced. Okay, so that's what they did here. So over with the variable, they were adding 1,176. So what we're going to talk about when we solve these equations, we're going to do the opposite operation. So since over with the variable, they were adding, we need to subtract to get that to cancel out. Now, normally to write that, and we'll show more examples as we go here, but normally to write that, rather than writing all this stuff, rewriting it all again, we can just do this. This is normally how these problems will be worked out. So we can just subtract right underneath it, and then you can draw a line through that to show that those cancel out. Over on the right side of the equation, if you subtract those numbers, you would get 7,941. One thing else that you can do is where your equal sign is, you could put like kind of a dotted line or something going down. And the idea is that we don't want to move our equal sign. Sometimes I've seen people move the equal sign to a different spot in the equation. Just try to keep bringing your equal sign straight down. The nice thing about these problems, once you get your answer, you can substitute it back into the original equation and see if it works. So once we got this answer, substitute it back in the equation, and when you add those numbers, then it works. Then you know that you have the right answer. So the Fort McHenry Tunnel is 7,941 feet long. So a couple of examples here. If we want to solve this equation, what they're saying is that they're adding -5, so we would do the opposite. We could subtract -5. Now the deal is, though, when you subtract -5, we've talked about it, that you can add the opposite. So subtracting a -5 is the same as adding a +5. And then 12 plus 5 would be 17. We're not getting into it quite yet in this lesson, but you could, if you wanted to, you could just think about, how do I cancel out a -5? So cancel out a -5, I would need a +5. Okay, kind of like if you owe $5, you have to pay back $5 so that you don't have a debt to that person. And then notice we get the same thing. So whichever way makes more sense to you, if you want to do the opposite operation and add the opposite, or if you want to just say, well, to get rid of a -5, I need to add 5. And then we can check our answer. 17 plus -5 would be 12. Kind of like if you had $17 and you spent $5, you would still have $12. And the very bottom of the page, they talk about this again. They already mentioned it earlier, but equivalent equations have the same solution. So when we take an equation and we solve it, if we solved it correctly, those original equation and our answer would be equivalent equations. On the next page, what they talk about in your book is that the variable might be on the other side of the equation, and that's okay. We're just going to always look at what's over with the variable, what do I need to do to get rid of it. So on this problem, probably the first thing I would do before I even got started on this would be to go ahead and take the absolute value of -6. How far is -6 from 0? And that would be 6 units away. And then if you look over with the variable, they're adding 24. Also, there's not a sign to the left of this. We know that would mean that that's a +24. So to get rid of that, we would need to subtract 24. So probably I would have just rewritten the problem before I got going with this and done the absolute value first. And then to get rid of a +24, we need to subtract 24. And we need to do that on both sides of our equation. Again, if you want to draw this imaginary line here and make sure you're doing the same thing on both sides, that you're keeping it balanced, you can do that. In order to work this out, you may want to work this to the side. 6 minus 24. You can add the opposite, 2 sign changes. So 6 plus -24, these are working against each other because they're different signs. So we're going to take the difference, which would be 18. And we have more that are negatives. Okay, like if you had $6 and you spent $24, you're going to owe some money. You're going to owe $18. Okay, so this would be our solution. And you can see in the book where they substituted that back in and made sure that it worked. The next thing they mention in your book is that sometimes we can combine like terms when we solve an equation. That's just going to make it to where we don't have as many steps. So instead of on this problem, if we're solving this problem, instead of saying, okay, now first I'm going to subtract 12 on both sides, that gets rid of the 12. Now I'm going to subtract 5. Now I'm going to subtract -8. That's several steps for us to do. So one thing you could do, like the book mentions, you could use the commutative property and rearrange the order and get all those constants next to each other. If you're careful with it, you might be able to just combine them as they are without rearranging it. So if you do that, 12 plus 5 is 17 if you want to combine the positives together first. And then besides that, we have a negative 8. So then 17 plus negative 8, or 17 minus 8, would be 9. So that simplifies the equation to where we have d plus 9 equals 41. And then they're adding 9, so we could subtract 9 on both sides of the equation. Again, keeping that equal sign coming straight down all this time. And then if you work that out, 41 minus 9 would be 32. And once again, the book substituted that back in to the original equation, and they checked to make sure it worked. If you were checking this, what I would probably do, these are all like terms on the left side, they're all constants, but I would probably go ahead and just add the positives together, which would be 49. And then we've got 49 plus negative 8. So I'd probably just do one extra step here than what the book's doing. And then that would be 41, so that works. You can also estimate, possibly do mental math to see if your answer is reasonable. So in this example, 436 plus x equals 575. What they did is just rounded these off. They said 436 is about 440, 575 is about 580. It just gives you a little bit easier numbers to work with. And then since they were adding, well, they're using mental math here actually, so they're not going through the steps. They're just thinking, okay, if these are nice even numbers for me to work with, then I could maybe just in my head think this out and figure out that I could add 140, okay? That might be a little bit of a stretch to be able to always do that way, but you know, we do have this idea of estimation, or if nothing else, you know, you could work it out regular. Like we have been doing, and then, you know, work that out to get 140. If you'll notice this, they have this kind of squiggly equal sign in between on this problem at the end, and that means is approximately equal to. So since we rounded, since we estimated, then it's not an exact answer, but it's an estimate, so we say it's approximately equal to that. And then they solved just to double check. So if we look at the try these, we're going to look at these first 4 questions here. They want us to solve and check these answers. So this would probably be more of a good starting point for a problem for us to look at. This would be something we would have done last year. So we could say x plus 9 equals 21. I know some of you could just figure out what the answer is without doing the steps, but you need to show your steps the way that I'm showing you, because the problems are going to get more complicated, and if you don't get practice showing your steps on these easier problems, once we get into more complicated problems, you're not going to know what to do. Okay? Trust me, you're going to have to show your work the same way in high school, so the earlier you start getting used to that idea, then the easier it'll be for you later. So on this problem, you can see they're adding 9 over on the side with the variable. If they're adding 9, we're going to do the opposite operation. So if they're adding 9, means we need to subtract 9. We're going to subtract 9 on both sides of the equation. 9 minus 9 is 0, so those cancel out. And then 21 minus 9 would be 12. So x equals 12. And then it says to check our answer, so I'm just going to rewrite the original equation. Doesn't take but a couple of seconds. And then technically when we substitute it in, like we've talked about, we should put an equal sign, or we should put a question mark above the equal sign there. 12 plus 9, if you add those, that is 21. Once you know that they're equal, you don't have to put the question mark there anymore. And so that's our check. Number 2, the variable's in a different position here. It's not first, but they are adding either way. So they're adding 52, means we need to subtract 52. We need to do the same on both sides of the equation. Okay, and the difference between now and last year is that you need to understand sometimes your answers might come out negative, and that's going to be the case here because we've got 37 minus 52. So if you had $37 and you spent $52, you would have had to borrow some money. So we can add the opposite here, 37 plus negative 52. Those are different signs, so we need to subtract. We need to take the difference. And we know that we had more that were negatives, so make sure you remember a negative here. So s is equal to negative 15. And then we can go to check our answer. So 52, well, let me write the equation again first. So 52 plus negative 15, is that equal to 37? And those are different signs, so you could subtract 52 minus 15, and you get 37, so we know we have the right answer. Number 3, you've got a couple options. To be consistent with what we've been doing, you could say they're adding. Negative 2 means we need to subtract negative 2. Just understand that you could add the opposite there. And you can add the opposite on both sides if you want. Negative 2 plus 2 is 0, so those cancel. And then 12 plus 2 is 14. So y equals 14. I'm not going to switch those around. You can just say 14 equals y. Just to mention something to you, though, if these things are equal, you can switch sides if it really bothers you. So in other words, if these are equal, if you don't like the variable being on the right side, don't change the order, but you could switch what's on what side. So you could do y plus negative 2 equals 12. And then you could work it out, okay, if that's easier for you to look at. Okay, so once you have solved the equation, they want us to check that. So 14 in place of the y, substitute that in. 14 plus negative 2, different signs, take the difference. And 12 equals 12, so that is the correct answer. And finally, number 4, I would go ahead and take care of the absolute value first. Absolute value of negative 7. How far is negative 7 from 0? Would be 7 units away. And this one's got a little bit of everything. So we have the absolute value. Another thing we have on this problem, if you'll notice, we still have 3 terms on the left side of the equation. So we actually have some like terms we can combine. If you want to use the commutative property to rearrange those, you can. But otherwise, 7 plus 1 is 8. Also at this point, since those are being added, 8 plus w, if you like the look better of w plus 8, you can switch it around, but if you can just deal with working with the problems in the order that they're in, that's might be helpful for you as you go along. So they're adding 8. This is a positive 8, so we need to subtract 8 on both sides of the equation. And this one you can add the opposite here, and that would be negative 19. So if we go to check this, put a negative 19, substitute that in place of the w. So absolute value of negative 7 is 7. Seven plus 1 is 8. If we combine like terms. And then 8 plus negative 19, different signs, take the difference. And we have more that are negative. So negative 11 equals negative 11, so that works. So this gives you an idea of how to solve addition equations. These problems you're going to want to work out in your notebook so that you have enough room. And like I said, show the steps the way that I've been showing them here, because that's how you're going to have to show these through high school. So the earlier you get used to that, the more practice you get, and the better you'll get at that. Have a good day.